This problem considers the reactions of ionic compounds in solution, and it considers also the limiting reactant concept. But first, in part A, it asks us what volume of 1.5 molar lead to acetate solution contains 0.400 mole of lead to ions. First of all, let's write the formula. Pb C2H3O2 taken twice dissolves in water to give Pb 2 plus, lead 2 plus ion, aqueous, plus 2 acetate ions, C2H3O2, aqueous. So, lead to acetate is a strong electrolyte. The relationship between the molar concentration, the volume, and the number of moles is as follows. First of all, the molar concentration is the ratio of the number of moles divided by the volume in liters. So we can solve this. V in liters will be equal to the number of moles divided by the molarity in moles per liter. So moles over moles per liter will give liters. So in order to determine the volume of lead 2 acetate that contains 0.4 moles, we can say the volume in liters is equal to 0.400 mole of lead 2 divided by the molar concentration 1.50, this is mole per liter of lead 2, and that number is 0.267 liters of Pb, and I'm going to abbreviate acetate as AC here. We do that sometimes, AC2 solution. Okay, so in order to get 0.4 of a mole, we have to take 267 milliliters, 267 milliliters of lead to acetate solution. That's 1.5 molar in concentration. The second part of the problem says when this volume, meaning the 267 milliliter, reacts with 125 milliliters of 3.4 molar sodium chloride, how many grams of solid lead 2 chloride can form? Lead 2 chloride is insoluble in water, and so the reaction would look something like this. Pb, acetate taken twice, aqueous, plus, I'll balance this, 2 sodium chloride, aqueous, goes to PbCl2, solid, and here I know this is solid because I know the solubility rules, plus 2 NaAC, sodium acetate, aqueous. So we're referring to the amount of solid that we can produce by taking 267 milliliters, and more importantly, this 267 milliliters, we could save ourselves some trouble if we remember that it's 0.400 mole of lead 2 plus that's in that 267 milliliters. Okay, so we have that, and then over here we have 125 milliliters of 3.4 molar sodium chloride. and we want to know how much lead-2 chloride forms. And that, of course, will be determined by which of these is a limiting reactant. So in order to find that out, we start with both of them. We convert the amount of lead acetate that we have to lead chloride, and we can do this in moles. It doesn't have to be in grams or volume or anything. So that will be very easy, because we could start with 0.40 moles Pb 2 plus times 1 mole of PbCl2 per 1 mole of Pb2 plus, and of course that's 1 to 1, so we're going to get 0.400 mole of PbCl2 precipitate. That would assume that we have an excess of sodium chloride. Now, to figure out how much you could get from the sodium chloride, assuming you have an excess of lead-2 acetate, it takes a little bit more calculation. First of all, it's 125 milliliters of this solution, so that's 0.125 liters of NaCl. And now we're going to do a volume to mole conversion. This is the volume, so we will use the molar concentration, which is 3.4 molar. So this is 3.4 moles of sodium chloride in 1 liter. Okay, and now we have the moles of sodium chloride, and I'm going to take this over here a little bit where I have more space, and now all we have to do is to recognize that we have 1 mole of PbCl2 per 2 moles of sodium chloride from the balanced equation. Okay, now if I carry out this arithmetic, I will find that we get 0.213 moles of PbCl2. Okay, if we compare these two, this one versus this one, you can see right away that this is smaller. So that means NaCl is limiting, and this is as much PbCl2 as we can get from the reaction. Now, the problem asks for grams of lead-2 chloride, so we have one more step here. So we'll do the final step to get the final answer. 0.213 moles of PbCl2 times, now the molar mass of PbCl2 is 278.1 grams PbCl2 per 1 mole of same, and that gives us 59.2 grams of PbCl2, starting with 267 milliliters of the lead acetate solution, 1.5 molar, and 125 milliliters of 3.4 molar sodium chloride. You can't answer the question until you determine which of the reactants is limiting, because it does not say that the two amounts that were given are in stoichiometric equivalency.